Noemie Ricahuerta and welcome to our tutorial. For this video, we're going to talk about vector. At the end of this tutorial, we are aiming to discuss the vector's functions, operations, applications, and the formulas for computing problems. So for the vectors, we have a large array of applications. It is regularly used in the field of engineering, structural analysis, navigation, physics, and mathematics. In real-life application by air traffic controllers when tracking planes, by meteorologists when describing wind conditions, and by computer programmers when they are designing virtual worlds. Now, let's differentiate scalar and vector. Scalar quantities are quantities with the magnitude only, like area, volume, mass, distance, speed, temperature, and etc. Well, the vector quantities, these are the quantities with magnitude and direction, like for example, the weight, displacement, velocity, torque, momentum, and many more. In engineering mechanics, we're familiar in vector, right? For example, we have force P, which is 100 newtons, and have an angle of 30 degrees. So in order to get our x and y components, we will be using this formula. We have the P sub x equals to P cosine theta. So that will be 100 cosine 30, and that will give us the answer to 86.6 Newton. And for our P sub y, we have P sine theta. So that will be 100 sine 30. So that will give us the answer to 50 newtons. In vector form, we will be using this formula. So P is equals to P sub x multiplied by its direction, which is the I, plus P sub y multiplied by its direction, which is the j. So that will give us the answer to 86.6 I plus 50 j. In three-dimensional coordinate system, it's going to be different. So we have our three lines, which will represent the first line to our z-axis and its direction, which is the k. And for our second line, we have the y-axis, which have the direction of j, and the x-axis for the direction of I. For us to plot a point, we need to know the y, z, and x-axis first. For given a data or points, it is simply goes in an alphabetical order. So it will going to be look like this, x, y, and z. Now, our three-dimensional vector representation, or sometimes it called the vector in space, is going to be like this. In our three-dimensional coordinate system, we have our line K, J, and I. And we have the vector A. We get the parallel lines with respect to our vector A. For our A, Z. For our A, AY. And for our A, X. With respect to the angle. To get vector A, add all the vector axes with their directional unit. So we have the A sub xi plus the A sub yj plus the A sub zk. Now, this is the formula for our vector A. And then for the magnitude, just square each vector without their directional unit and all of them. And after that, get the square root. we have the A equals to the square root of A sub x squared plus A sub y squared plus A sub z squared. Okay, now that we're done with that, let's go to their angles. We're going to need a little knowledge about the trigonometry using the SOHCAHTOA. So our objective is to get the angle of our axis. For the cosine, that would be the adjacent over hypotenuse. For our angle alpha, we have here the A sub x over vector A. And for the angle beta, we have the A sub y over the vector A. And for our last triangle, we have the cosine gamma is equals to A sub z over vector A. The cosines of the angle alpha, beta, gamma are called the direction cosines. Alpha, beta, and gamma. This is the direction cosines. So let's designate them as L, M, and N. So this one is L, M, and N. So just add all of them and squared. You have the L squared, M squared, plus N squared is equals to 1. So that will look like this. Cosine squared alpha plus cosine squared beta plus cosine squared gamma is equals to 1. Now let's go to vector along vector. So unit vector is equals to the vector over the magnitude vector. So we recall that the magnitude vector is just simply the square root of cosine squared alpha plus cosine squared beta plus the cosine squared gamma. For our vector A is equals to the A sub xi plus A sub y j, then plus the A sub z k. Notice that the cosine theta is equals to A. Therefore, our unit vector is equals to cosine alpha I plus cosine beta j plus cosine gamma k. If you want to find the vector A, given the magnitude of the vector and its unit vector, just multiply the unit vector and its magnitude. A is equals to the unit vector times the magnitude vector. Is equals to magnitude vector times the cosine alpha I plus cosine beta j plus cosine gamma k. Yay! We're almost done, guys. So if the 2 dimensions has an operation of vector, so has the 3 dimensions. So first is the vector connecting 2 points. Do you have any idea how to get it? Let's say you have given vector r with 2 points. So it goes like this. First, we need to draw a 3D plane. We have our z-axis, our y-axis, and x-axis. Let's say our point A is located here, and our point B is here. So in here, every point, we need to get the x, y, and z component. For our A, we have the x sub A, y sub A, and z sub A. Same with V. We have our x sub B, y sub B, and z sub B. Do you remember what I said before? That another way to determine the vector is through the directed line segment. So, we will connect our point A to point B. And now, we have our vector r. In finding vector r and its magnitude, when you have 2 points, just subtract the value of a to the value of b, just like finding its distance using the distance formula. So in getting vector r, we have our x of b minus x of a times the direction, which is the I, plus y sub b minus y sub a times the direction, which is j, plus z sub b minus z sub a times k. So, for finding the magnitude of vector r, this is just simply the r is equals to the square root of quantity of x sub b minus x sub a times the direction, which is the I, and then squared, plus the quantity of y sub b minus y sub a times j, and then squared, plus quantity of z sub b minus z sub a times k, and then squared. Now, let's proceed to the vector operations. We have 4 types of vector operations, which are the cross product, the resultant of 2 vectors, the dot product, and the angle between 2 vectors. For the vector operation cross product, just simply multiply the pivot to the remaining matrix. So we have the pivot I times the a sub 2, a sub 3, b sub 2, and then the b sub 3, minus the pivot j, then times the a sub 1, a sub 3, b sub 1, b sub 3, plus pivot k times the matrix of a sub 1, a sub 2, b sub 1, and then the b sub 2. Okay, so now let's proceed to the second type of vector operations, which is the resultant of 2 vectors. Just simply add the 2 vector along with its x, y, and z axis, then multiply it by its direction. So for this one, we have our quantity of a sub x plus b sub x times I plus the quantity of a sub y plus b sub y times j plus the quantity of a sub z plus b sub z times the direction, which is the k. Another vector operations are the dot product and then the angle between vectors. For the dot product, just simply multiply the vector a and then the vector b times the cosine theta. Or just simply multiply the vector a and then the vector b along with its x, y, and then z axis. We have it here the quantity of a sub x times b sub x plus the a sub y times b sub y plus the a sub z times the b sub c. And for the angle between vectors, just divide both sides by vector a times vector b. So we have it here, the cosine theta is equals to the dot product of vector a and b over vector a times vector b. And for getting the angle, this one is arc cosine of dot product a and b over the vector a times vector b. Let's now solve problems about vectors in 3-dimensional. So we have our example number 1. A force is defined as F is equals to 100I plus 200J minus 300K. So determine its magnitude in Newton. Find its alpha, beta, gamma, and its unit vector. So we have our Fx is equals to 100. Our Fy will be 200. And our Fz is equals to negative 300. So, in finding the magnitude, we will be using our F is equals to Fxi plus Fyj plus Fzk. So, since its magnitude, there will be no direction. So, we tend to use square each one component. So we have our fx plus fy plus fz. So that will give us the formula to f is equals to the square root of fx squared plus fy squared plus fz squared. So substitute the given. F is equals to the square root of 100 squared plus 200 squared plus negative 300 squared. And that will give us the answer to 374.166 Newton. We will be using this formula. So for the alpha, we have arc cosine of fx over f. So that will give us the answer to 74.499 degrees. And for the beta, we have cosine, arc cosine fy over f. So we have arc cosine fy, which is the 200 over 374.166, and that will give us the answer to 57.688 degrees. And last, for our gamma, we will be using arc cosine of fz over f, which is fc is negative 300 over 374.166, and that will give us the answer to 143.3 degrees. For the unit vector, we will be using this formula. So you underline cosine alpha I plus cosine beta j plus cosine gamma k. So substitute cosine of 74.499 I plus cosine beta, which is 57.688, plus cosine gamma 143.3. That will give us to the answer of 0.267I plus 0.535J minus 0.808K. Example number 2. A 400 Newton force creates an angle of alpha is equals to 50 degrees, beta of 60 degrees, and gamma of 70 degrees. So, find the vector component of force. So, we have the alpha is equals to 50 degrees, beta of 60 degrees, and gamma of 70 degrees. So, we have the force, which is 400 newtons. In order for us to get the vector component, we will just use this equation, which is the cosine theta is equals to F component over the F. So just simply cross multiply to get the F component. So we will have our F cosine theta. So for our alpha, we have Fx is equals to F, which is 400, and then cosine of 50 degrees. And that will give us the answer to 257.12 Newton. And for our Fy, we have 400 cosine of 60 degrees. So, we have our 200 newtons. And for our Fz, that is equals to 400 cosine of 70, and that will give us the answer to 136.809 Newton. Let's try another example. We have at 1,300 pound force has an X component of 900 pounds and Y component of 700 pounds. So determine its Z component, the values of alpha, beta, gamma, and the unit vector of force. So we have our given force of 1,300 pounds. Fx is equals to 900 pounds and Fy is equals to 700 pounds. In getting the Z component, we will be using this formula. F squared is equals to Fx squared plus Fy squared plus Fz squared. So, just simply transpose the Fz. We have our Fz squared is equals to F squared minus Fx squared minus Fy squared. So, squared each, we have Fz is equals to the square root of F squared minus Fx squared minus Fy squared. Just simply substitute the given. We have Fz, the square root of 1,300 squared minus 900 squared minus 700 squared. And that will give us the answer to 624.5 pounds. In order to get the alpha, beta, gamma, we will be using this formula. So we have our cosine theta is equals to F component over F. So for getting the angle, we have the arc cosine of F component over F. For our alpha, that will be arc cosine of Fx, which is 900, over 1,300. And that will give us to the answer to 46.187 degrees. For our beta, we have arc cosine of 700 over 1,300. And that will be 57.42 degrees. Last, for our gamma, we have arc cosine of Fz, which is 624.50 over 1,300. And that will give us the answer to 61.29 degrees. Now we're done for getting the alpha, beta, gamma. For our unit vector, we have our formula of U underline of cosine alpha I plus cosine beta j plus cosine gamma k. Just simply substitute the following. So we have our cosine 46.187 I plus cosine of 57.42 j plus cosine of 61.29 k. And that will give us to the answer to 0.692 I plus 0.538 j plus 0.480 K. Another example, a 300 Newton force passes from point A of 3, 5, 2 to point B of 6, negative 3, and negative 5. So determine the rectangular form of the force and also find its angle and its unit vector. So we have the given of force is equals to 300 Newton. And for our point A, which will give us to X, Y, and Z. For our XA, we have 3, YA, 5, and ZA of 2. For our point B, we have XB of 6, YB of negative 3, and ZB of negative 5. The formula we'll be using is R is equals to XB minus XA, I for the direction, plus YB minus YA, J plus ZB minus ZA of K. So, just simply substitute the following given. XB, 6 minus 3 times I plus Y minus B, YB minus YA. So we have negative 3 minus 5 J plus ZB, which is negative 5 minus 2 multiplied by K. So we have 3I minus 8J minus 7K. And this will become our rectangular form. Now, for getting the angle, beta, and gamma, just simply use this cosine theta equals to F component over F. For getting the angle, we have theta is equals to arc cosine of F component over F. For getting alpha, we have arc cosine of Fx, which is the 3 over 300 Newton. And that will be 89.470. For our beta, we have arc cosine of negative 8 over 300, and that will be 91.58. And last, for our gamma, we have arc cosine of negative 7 over 300. That will be 91.337. Now, for getting the unit vector, we have cosine alpha I plus cosine beta J plus cosine gamma K. That will be cosine 89.470 I plus cosine of 91.528 J plus cosine 91.337 K. And that will give us the final answer of 0.01 I plus or minus 0.03 J minus 0.023 K. And that's it. Another example, a force F is equals to 100I minus 300J plus 500K Newton passes through point A of 2, negative 3, and 5. So determine the magnitude of the moment of this force about the origin. So first, we have to get the resultant force based from the given. we have our force is equals to 100I minus 300J plus 500K Newton. So we have point A of 2, -3, and 5. For getting this one, we have this formula of f squared is equals to fx squared plus fy squared plus fz squared. And then squared, we have our f is equals to the square root of fx squared plus fy squared plus fz squared. Just substitute the following. We have f is equals to the square root of 100 squared plus -300 squared plus 500 squared. And that will give us the answer to 591.608 Newton. For getting the radius, we have this formula of r squared is equals to xb minus xa squared I plus quantity of yb minus ya squared j plus quantity of zb minus za squared k. So just simply squared to get r. Now we have our r for square root of quantity of xb minus xa squared I plus quantity of yb minus ya squared j plus quantity of zb minus za squared k. So since we only have point A, let's assume our point B is all 0. So we will now have our r square root of xb, which is 0 minus 2, our a squared I plus yb 0 minus -3 squared j plus zb, which is 0 minus 5 squared k. We have 4 plus 9 plus 25, and that will give us the answer to r is equals to the square root of 38 meters. Now for getting the moment, just simply multiply the force and the radius. So that's 591.608 Newton times square root of 38. That will be 3,646.92 Newton meter. And that's all. Another example, two forces are defined as A is equals to 250I plus 400J minus 800K, and B is equals to 40I minus 200J minus 250K. So find the following. For the A, find the magnitude of forces of A and B. For letter B, the resultant of A and B, which is the magnitude, vector component, angles projected, unit vector, if they are acting at the same point. And for C, the dot product, AB, and the angle between them. And last, the cross product of A and B. So for letter A, we have this equation of A is equals to AX squared plus AY squared plus AZ squared. So take note that our AX is equals to 250, our AY will be 400, and AZ is negative 800. Now, let's substitute the following. We have for A, it's just the square root of 250 squared plus 400 squared plus negative 800 squared. And the answer will be 928.71 Newton. And for B, our Bx will be 40, our By will be negative 200, and our Bz is negative 250. And we have for B, the square root of Bx squared plus By squared plus Bz squared. Just substitute the given. The square root of 40 squared plus the square root of negative 200 squared plus the square root of negative 250 squared. And our B will be 322.645 Newton. For letter B, the resultant of A and B, and we get the magnitude, vector component, angles projected, and then the unit vector. We have our AX, which is 250, our AY, 400, and AZ, negative 800. For our BX, we have 40, our BY is negative 200, and BZ, negative 250. For getting the resultant, we have this formula of FR. It's just simply the AX plus BX I plus BY plus AY J plus AZ plus BZ K. Just simply substitute the given to the equation. It's 250 plus 40 I plus 400 plus negative 200 J plus negative 800 plus negative 250 K. And that the answer will be 290 I plus 200 J minus 1050 K. For getting the magnitude, we have this formula of F is equals to the square root of Fx squared plus Fy squared plus Fz squared. So we have our Fx as 290, our Fy of 200, and Fz negative 1050. Just substitute the given to the equation. Now we have the square root of 290 squared plus 200 squared plus negative 1050 squared. And our answer will be 1107.52 Newton. For the angles projected, we use this formula of cosine theta is equals to F component over F. And for getting the angle, we have theta is just simply equals to arc cosine of F component over F. For our alpha, we have arc cosine of Fx, which is 290, over F, 1107.52. And our alpha will be 74.82 degrees. For our beta, we have arc cosine of Fy, which is 200 over 1107.52. And our beta will be 79.59 degrees. And lastly, for our gamma, we have arc cosine of Fz, which is negative 1050 over 1107.52. And our gamma will be 161.45 degrees. And now, for getting our unit vector, we have this formula of u underline is equals to cosine alpha I plus cosine beta j plus cosine gamma k. You will just simply substitute the following given to the equation. Now we have our cosine for the alpha, which is 74.82 I plus cosine beta, which is 79.59 j, and our cosine gamma, which is 161.45 k. And that will be 0.262 I plus 0.181 j minus 0.948 k. And that will be for letter. For the dot product AB and the angle between them. So for the dot product, we have this formula of A dot B is equals to AB cosine theta is equals to AX BX plus AY BY plus AZ BZ. So for our F1, F2, just simply AX BX plus AY BY plus AZ BZ. We just simply substitute the following given to the equation, which is for our AX 250 times BX 40 plus our AY 400 times negative 200 plus our AZ negative 800 times negative 250. And that will be 130,000. Now for our F1, F2 cosine theta. We have the square root of AX squared, AX plus AY squared plus AZ squared. This is for our A. Times the square root of BX squared plus BY squared plus BZ squared. So substitute for our A, the square root of AX 250 squared plus AY 400 squared plus AZ negative 800 squared times the BX, the square root of BX 40 squared plus BY, the negative 200 squared plus BZ negative 250 squared. And our F1, F2 cosine theta will be 299,643.5. And now, we will just simply equate the following. That will be 130,000 is equals to 299,643.5 cosine theta. So, just divide both sides to 299,643.5. And now we get our theta. Cosine theta will be 4.33 over 9.988. And our theta will be arc cosine of 4.33 over 9.988. Our theta now will be 64.31 degrees. For the cross product, A times B, we usually do the matrix. We have the direction of I, J, and K. We have 3 columns and then 2 rows. For our F1 times F2, we have 250, 400, negative 800, 40, negative 200, and negative 150. So for getting the cross product of I, we have 400, negative 800, negative 250, and negative 150 times I, minus, for our J, we have 250, 40, negative 800, negative 150 J, plus, for our K, we have 250, 400, 40, and then negative 200. Now, for getting this one, we have F1 times F2 just simply equals to quantity of 400 times 150 times negative 150 minus negative 200 times negative 800, quantity I, minus 250 times negative 150 minus 40 times negative 800 J, plus quantity of 250 times negative 200 minus 40 times 400, quantity of K. So our F1 times F2 will be negative 220,000 I minus 5,500 J minus 66,000 K. And that will be all. That's all for today, guys. I hope that you learned a lot from our discussion. Thank you for watching, and I wish you have a blessed day, future engineers. Always remember, a quitter never wins and a winner never quits.